In our prior video, we looked at how you did multiplication and division with Sig Figs. And you may recall that at one point we did a calculation, and what we found was that we got a value of 1,111 miles per hour, but we were only allowed to keep one sig fig, and so we rounded that to 1,000 miles per hour. And you might think to yourself, well, I can see why this has 4 sig figs, but why doesn't this also have 4 sig figs? What's going on with these zeros? And so this raises the question, which digits count as sig figs in a number? So which digits do we count as sig figs? And that is the topic of this video. So what we're going to give you here are the rules for counting sig figs. Okay. And so the first thing you need to know, very straightforward, all digits 1 through 9 are always significant. So those are easy. So, excuse me, all digits 1 through 9 are always significant, are always sig figs, as it were. And so 1 is always significant. There are 4 ones there. That has 4 sig figs. So the question this leads for us to determine is, when do zeros count? That's really the only thing you need to worry about. The zeros are the tricky one. And you can kind of see these zeros must not have counted, right? This had 1 sig fig, we said. That guy was significant, and those apparently weren't. So what are the rules for zeros? And what you really want to ask yourself, if you think of it as a measurement, are these zeros measured values? And if you did measure it and it was really 0, that's a significant figure. Or are they just placeholders? And we'll explain what a placeholder is as we go along here. But placeholders are not going to count as significant figures. They aren't really measured values. So essentially there are 3 places where you can find zeros. A 0 could exist to the left of all your significant digits. And if zeros are to the left of all significant digits, they never count. Those ones never count. And really what's happening is there's nothing to measure out there, and I'll explain what we mean by that. But that's why these aren't really measure values. And if they exist at all, they're just placeholders. So let's imagine the number 156. That looks like it has 3 sig figs. Now, I could certainly put a 0 in front of it. That's still the same number, 156. In fact, I could put as many zeros as I want out there. But those aren't significant figures. And the reason is, you're not really measuring anything by putting those zeros out there. If something is 156 centimeters long, and you say, okay, so that means it's 0 thousands, but you're not measuring anything. There are no thousands to measure here. So adding more zeros isn't going to help you any. And all you're going to get here are 3 sig figs, the 3 digits that you have. And that usually makes pretty good sense to most people. Now let's imagine that we instead say the number 0.000156. Okay. Well, again, this only has 3 sig figs. If you look at our rule, these zeros are to the left of all your sig figs, all your digits, so they're not going to count. But the reason is, this would be what, the tenths place, the hundredths place, the thousandths place. There are no thousandths to measure there. This number is smaller than that. The smallest, or the largest thing you have is the 1 in the 10,000ths place. Okay. There is no thing to be measured at that point. So those zeros don't count either. One way you could think about this, imagine this number was 0.000156 kilograms. Well, if we change this into grams, there are 1,000 grams in 1 kilogram. So we use our unit analysis method here to see how many grams this is? Well, it would be 1.56 grams. Do we need those zeros anymore? Would you write 0, 0, 0, 1.56? Of course not. These zeros aren't necessary. What are they doing? They're what we call placeholders. The reason you need these zeros here isn't because they measure anything. It's because without them, you don't know that this is the 10,000th place. If you get rid of those zeros, this looks like the 10th place. So they're placeholders. They tell you what place that one is in. And so those zeros to the left of all digits never count. Now, you could also have zeros to the right of all digits. Okay. These ones count if they are also to the right of the decimal place. So they sometimes count, but they have to also be to the right of the decimal place. So let's take a look at some examples of that. Our first number we might look at, remember we measured that line and it was 0.4 meters long? That has one sig fig pretty clearly. I could change it into a measurement in millimeters. There are 1,000 millimeters in 1 meter. That means that line would be 400 millimeters long. Did I somehow gain some sig figs by converting from meters to millimeters? I don't really know any more than I used to. Only the 4 is significant. What role these zeros are playing? They're placeholders. They're only there to tell you that this 4 is in the hundreds place now. But I didn't actually measure that that line was exactly 0.4 meters. Remember, we measured it with that meter stick that was all taped up. We don't know exactly how many millimeters it is, but we know it's in the 4 in the hundreds place, or 0.4 meters. So these zeros, not significant, just placeholders. And according to our rule, they're to the right of all the digits, but they're not to the right of the decimal place, so they don't count. We only have one sig fig. But now, imagine that somebody had recorded a measurement as 0.4, so decimal point 400 meters. Okay. Why are these zeros here? The 4 is clearly significant, but these zeros, according to our rule, are also significant. They're to the right of the digits and to the right of the decimal place. Why do they count? Well, think about it. Why did we write 0 there? We didn't need them as placeholders. If I make those disappear, it's still the same number. It's not telling me anything different. The only reason to write zeros there is to say, you know what? I actually measured the hundredths and the thousandths place here, and they were both 0 too. I'm claiming to know them if I write those zeros. It's the only reason to really put them there. And so those zeros will count. So now if you think back to when we measured 1,000 miles per hour, those zeros don't count. The 1 counts. The zeros are to the right of the digits, but they are not to the right of the decimal place, and therefore they do not count. Okay, so one other spot zeros can be. They can be all the way to the left, they can be all the way to the right, or they can be in the middle between digits. So the third piece you need to know is that zeros that are found between sig figs always count. Okay, so those ones will always count. And let's look at an example here. If I have 101 centimeters, the ones both count because they're digits. The 0 counts because it's between them. And what we're essentially saying is if I measured the hundreds place and I measured the ones place, certainly I know the tens place also. And in this case, it just happens to be 0. So that is a measured value. So this would have 3 sig figs. Okay, this 0 is not just a placeholder, it's actually a measured value. Now, what if I have the number 100.0? Let's again make that centimeters just to give it a unit. Clearly the 1 is significant. Now, by rule 2, this 0 is to the right of the digits and to the right of the decimal place. Therefore, it's significant. The only reason to write 0 here is to say I measure that and I know it's 0. I don't need it as a placeholder. 100 is still 100. But if this is significant and this is significant, if I measure the hundreds place and the tenths place, I must also know the tens and the ones place. So this would in fact have 4 sig figs. Now, one more example. Let's say 0.01010. So what's significant here? Digits, always significant. The 0 all the way to the right is significant because it's also to the right of the decimal place. The only reason to write it is because I know it's a 0. This 0 is significant because it's between significant digits. This 0, not significant. This is a placeholder. I need it so that I know that this is the hundredths place and not the tenths place. Okay, so here I've again got 4 sig figs. So those are your rules for counting sig figs. All digits 1 through 9 always count. Zeros are the only thing you have to worry about. If they're to the left of all the digits, they never count. If they're to the right of all the digits, they count if they're also to the right of the decimal place. And if they're in between significant digits, like this 0 or these zeros or that one, they will always count if they're between those digits.